welcome to this episode on Wisdom Mathematics tutorial on limits. We have a question which says find limits of f of x equal to x plus 3 over x squared plus 5x plus 6 as x approaches minus 3. In our previous episode on limits, we solved questions like finding limits of f of x, which is something like x plus 3 all over 2 as x approaches 1. And in that episode, we explained that when the denominator is an integer, we can solve this as if we are solving for f of 1. That is simply substituting the x in this expression by 1. Or if you have something like x squared, here we have 3. The same thing, we solve it as if we are looking for f of 3. That is substituting this 3 for x in this expression. So ordinary substitution directly into what we have. But in a situation like this particular one, whereby the denominator is not just an integer but a polynomial or another expression which is not just a constant like these two. So we are not just going to substitute the 3 here into it directly. Just like in this case, we have minus 3 as x approaches minus 3. So we are going to take minus 3 to substitute for x. We cannot do it directly into this particular type of question, but we can do it into this type, because in this case denominator is just a constant, but here denominator is not just a constant but an expression of the same independent variable. So we are going to go another process before we can now do the substitution. So when you have a subject or a question like this, we are going to first of all try to express this fraction in another form before you do the substitution. So in this question, we are going to have that limit of f of x as x approaches minus 3 of x plus 3 all over x squared plus 5x plus 6. This is going to give us x plus 3 all over. We are going to express this. That is, get the factors of this, solving it as if we are solving quadratic equation by factorization method. The two factors we are going to use to substitute for this 5 here are 2 and 3. So we have x squared plus 2x plus 3x plus 6. So this particular quadratic expression here, we are going to replace it with this. That is, solving this as quadratic equation using factorization method. We are going to get these two factors. When added, will give us 5x, but when multiplied, will give us 6x squared. So 2x and 3x will now replace 5x. So we can now factorize them, and this is going to give us x plus 3 all over. The factor here is x. We bring it out. We have x plus 2 plus the factor here is 3. We bring it out. We have x plus 2. So we're going to have that limit of f of x as x approaches minus 3 is now going to give us x plus 3 over x plus 3 here and x plus 2. So this can cancel this to give us 1 over x plus 2. So what we are trying to find now is limit of f of x. The f of x has reduced from this form to 1 over x plus 2. So we will now have 1 over x plus 2 as x approaches minus 3. So when we substitute, we are now going to substitute minus 3 for x here to give us 1 over minus 3 plus 2 to give us 1 over minus 1, which is minus 1. So you see that in this type of question, we are going to first of all solve this by factorization so that we check if it can be reduced further. As we have seen, we have x plus 3 here, and we have one of these two factors to be the same, x plus 3. So when we cancel out, we're now going to be left with 1 over x plus 2. So the function has now changed because of this process we have carried out. So it's now after this particular operation we have done that we can now substitute. Instead of substituting directly into this, we first of all resolve it to this before we do our substitution. Then we arrive at our final answer. So go through this very well. From this point to this point is just solving quadratic expression by factorization. They're going to get these two factors. Then you can visit our channel, Wisdom Mathematics channel, to see the questions we have solved using factorization method, so that you will learn how we can get this x plus 3 and x plus 2 from that particular episode. Then putting it here, we now understand this to the fullest. See you in the next class.